You probably know that 66 million years ago, a huge asteroid crashed into Earth, causing a mass extinction that killed off most of life on this planet, including the non-avian dinosaurs. But did you know that some of the plants that we see today, like roses, orchids, and grasses, were already around before the asteroid hit? How did they manage to survive the cataclysmic event that changed the course of evolution? Well, you've come to the right place, because that's what we're going to talk about in today's episode. I'm your host, MrEarthGuy, and you're listening to Earth SciShow. In a brand new study, researchers used a novel approach to estimate the extinction rates of flowering plants, also known as angiosperms, across their entire history. This is from their origin, about 250 million years ago, to present day. Angiosperms are the most diverse and abundant group of plants on Earth, with about 290,000 species. They are also the most important for us humans, as they provide us with food, medicine, fiber, and many other products. But how did they become so successful and resilient? Well, one of the key events in their evolution was the Cretaceous-Paleogene mass extinction, or KPG. This was the fifth and most recent of the major mass extinctions in Earth's history, and it marked the end of the Mesozoic era and the beginning of the Cenozoic era. The Cretaceous mass extinction had huge impacts on the biodiversity of the planet, wiping out about 75% of the species that existed at the time. Among the victims were the non-avian dinosaurs, the pterosaurs, the marine reptiles, and many groups of plants and animals. But not all life forms were equally affected by the asteroid. Some groups managed to survive and even thrive in the aftermath of the disaster. Among them were the angiosperms, the mammals, and the birds. The question is, how did they do it? How did they cope with the harsh conditions that followed the asteroid impact, such as firestorms, tsunamis, darkness, cold, and acid rain? To answer this question, scientists have used different sources of evidence, such as fossils, DNA, and family trees. Fossils can tell us which species existed before and after the asteroid, and how they changed over time. DNA can tell us how closely related different species are and when they diverged from common ancestors. Family trees can tell us how the branching patterns of different lineages reflect their rates of speciation and extinction. However, these sources of evidence are not always consistent or complete. Fossils are rare and unevenly distributed, and they may not represent the true diversity of a group. Additionally, DNA is only available for living species, and it may not reflect the true history of a lineage. And lastly, family trees are based on assumptions and models, and they may not capture the complexity of the evolutionary process. That's why this brand new study decided to use a new method to estimate the extinction rates of angiosperms across their entire history. They used large family trees that were constructed from DNA sequences of 33,000 to 73,000 species of angiosperms. These family trees represent the relationships among the major groups of flowering plants, such as families and orders. The authors then used mathematical models that compared the ages of the ancestors of each group with the expected number of species that should have evolved from them according to the evolutionary process. The model also compares the actual number of species in each group with the expected time that it takes for a new species to evolve. This way, the model can calculate the net diversification rate of each group, which is the difference between the speciation rate and the extinction rate. The model also divides the history of angiosperms into time intervals, such as millions of years, and calculates the diversification rate for each interval. This allows the authors to identify periods of time that had high or low diversification rates and to test how well the data supports these patterns. The results of the study were surprising. The authors found that the extinction rates of angiosperms were remarkably constant over the last 140 to 240 million years. This means that the Cretaceous mass extinction had little effect on the extinction rates of flowering plants, and that they were able to survive and diversify without major interruptions. This finding contrasts with the fossil evidence, which shows that many angiosperm species do go extinct around the Cretaceous boundary, and that some regions were more affected than others. The authors suggest that this discrepancy may be due to the fact that the fossil record is incomplete and biased, and it may not reflect the true diversity and distribution of angiosperms. The authors also suggest that the resilience of angiosperms to the Cretaceous mass extinction may be explained by their ability to adapt to changing environments. For example, angiosperms evolved new ways of dispersing their seeds and attracting pollinators, which increased their chances of survival and reproduction. They also evolved the ability to duplicate their entire genome, which provided them with more genetic variation and potential for innovation. The authors concluded that their study proves a new perspective on evolution of angiosperms, and it highlights their remarkable resilience and diversity. They also point out that their study has implications for the current biodiversity crisis, as many angiosperm species are threatened with the extinction due to human activities. They warn that the loss of species may have irreversible consequences for the ecosystems and the services that they provide. And that's all for today's episode. I hope you enjoyed it and learned something new. If you did, please leave a comment and share this podcast with your friends. You've been listening to Earth SciShow, and I'm your host, MrEarthGuy. And remember, stay curious.